Here's Lab 5. I thought that it would be helpful if you could compare what you had with the answers, and so I wanted to solve it and put up a video on it, and so here it is. So the first thing that it's asked you to find is the slope, and I always look for, like, that looks like it's halfway in between there, and that one looks like it's right there on, and I know that it's kind of lightly printed here, and maybe it's a little better on yours, but I'm kind of looking, that looked like it was halfway in between. And so I kind of came down here and found what I thought was another corner. Slope is the rise divided by the run. And you can do either, it doesn't matter. So I was taught to count from the left by Mr. Heater. So this point is the left. And if I went from that point to that point, just because that one's halfway in between, so I wasn't sure. So this would be 1, 2, 3, and I was taught to count the run first and to count from there. So I kind of, that distance right there to line up here is 3. So that distance, and I walked in the positive direction, so it's positive 3. And then I'm going to go up 1, 2, 3, 4, 5, 6. So in other words, I'm going this distance, and I went in the positive direction. Up is positive 6. So this slope is 2. Now you can see, I hope that you can see that if you counted the rise first, that it wouldn't matter, because this would have been 6, right, up, and then over 3. And so it wouldn't make any difference whatsoever. They're two separate things that you're getting, but it is a walk, and so from one to the other. So this is 2. And so this to me looks like it's halfway in between, and I just think to myself, if a person gives it to me looking halfway in between and asks me what it is, it must be halfway in between. So this is -1, and this is -2, so that's -1.5. And I'm going to write it in shortcut notation. It's definitely okay to write it as an ordered pair as well. So that would have been comma 0, -1.5, comma 0. The y-intercept is in shortcut notation is 3, and then that would be 0, comma 3. And then it asks you for the equation of the line. And the equation of a line, I can see that it's a slanted line. And how to find the equation of the line if it's horizontal. So find equation of line. If that's the directions, find the equation of the line. Then this is an if. If it's horizontal, then the equation is y equals a number, and all you have to do is figure out what that number is. If it is vertical, then the equation is x equals a number, and you just have to figure out what that number is. If it is slanted, and if you know the y-intercept, and remember the y-intercept is called b, then all you have to do, the equation builder, is y equals mx plus b. And you're replacing in m and b into that equation, right? M and b into that equation. You see them, that's not very good arrow going there, but m and b are going to be replaced in, and the equation of the line has x and y in it. Remember, a vertical line only has x in it, so you're not replacing anything in for x, just for the number. And m is a number, and b is a number, and same with the y. So then, for slanted, there's 2. If s, and you know, and if you know, so if slanted, and if you know a point, x1, y1, then the equation builder is y minus y1 equals m times x minus x1. Y and x are part of the equation of the line, just like y and x were the part of the equation of the line, part of the equation of the line, part of the equation of the line. And you're replacing in numbers for y1, for m, and for x1. And then the last step here is you have to solve for y. So there's a little bit more work if it is slanted and you don't know the y-intercept, but all the rest of them are just a matter of plugging in numbers. So in our case, it's slanted. I can tell that it's a slanted line, and I know the y-intercept. So I'm in the case right here where it's slanted and I know the y-intercept. So the equation, and I know b, right? So that's the type, slanted, and I know the y-intercept. So the equation builder is y equals mx plus b. And what was m? Well, m was 2. I found that. And remember, x is part of the equation of the line. And what is b? Well, b, it was 3, right? The y-intercept is what b is, so plus 3. So that's the equation of the line. Then this one here asks me to find the slope of the line, the x-intercept and the y-intercept, and the equation of the line. So that's what it's asking me to find. And I notice by looking at it, it's vertical. And all vertical lines have undefined slope. So I'm going to try to fit the whole word undefined in there. Got two D's going because of me trying to fit it in. Oh my gosh. It's like, oh, can you be so careful? Undefined, a little bit too long for me trying to write big. The other thing that your book puts, and I would accept as well, is no slope. So that would be fine. Where does it cross the y-axis? Excuse me, x-axis? Well, right there at -1. In that shortcut notation would also be accepted, -1, 0. Where does it cross the y-axis? Well, it does not cross the y-axis, so you have to put something like none. If you put 0, then you are saying that it crosses in the center, which it does not cross in the center. And so you will be marked wrong for that, even if that's not what you were meaning. You were meaning it does not cross. So if you want to write it does not cross on that tiny line, you can write it does not cross. I will take that as well. But your book puts none, and I think none's perfectly good. Now this is a vertical line, so I whip out my equation builder, right? If a vertical line, then the equation is x equals a number. So that's my equation builder, vertical, x equals a number. And what is the number for x? Well, it's -1. And in fact, if you look at every point on this line, like this one is -1, 1. And this point right here, 1, 2, 3 is -1, 3. And etc. On it goes. Every single ordered pair on that line has for x -1. And so that's why the equation is x equals -1, because every single one of the x's is -1. Not just one of them, not just the x-intercept, but it is, and also all of the rest of them. Here they're asking me to find the slope of the line and then the type of the line, horizontal, vertical, or slanted, and the equation of the line that passes through the pair of points. So we're going to do that. So we're supposed to find the slope, and good news, the slope will find us the type of line. So they've asked me to do something that will actually be helpful in identifying the next question that they're asking. So this is the formula for slope, called the slope formula for 2 points. So I'm going to be filling in here -7, and I'm going to be filling in here 9. And so the numerator there is -16, and my denominator, -2 and -3, looks like that's -2 plus 3, which is 1. So -16 over 1, which is -16. So my slope is -16. And the type of line, well, if the slope is 0, then it's horizontal. Well, that's not 0, so the line's not horizontal. So you can cross that out. And if it's undefined, the slope, if the slope is undefined, then it's vertical. Well, that's not undefined, so that leaves it slanted. Okay, and so all slanted means is it's not horizontal or vertical. Then they ask me for the equation of the line, and since I know that it's slanted, right, do I know the y-intercept? And so is this point right here the y-intercept? And the answer is no. In order to be the y-intercept, what you have to have is you have to have 0 in your X position if it's written as an ordered pair, right? So written as an ordered pair, is there 0 in the X coordinate? No, so that is not the Y-intercept. Now you can plot that point if you like. It's not necessary to plot it, but if I plot that point over -3 up 9, you can see that it did not land on the y-axis. So this is not the y-intercept, and neither is that. And you can plot that point too, if you like, -2, -7, somewhere down here, right? And it's not on the y-axis. So I am going to have to use this formula right here when you know that it's slanted, and if you know just a point. So that's what I know just a point, and that's called point slope, is the formula builder there. So it's y minus y1 equals m times x minus x1. And I've already labeled this one the ones, so there's no reason not to use it. So y minus 9 equals the slope, -16, times x minus -2. So resolve double negative, x plus 2, distribute, it's always the same, it's cookbook. So if you practiced it a few times, it's always the same on the solving and getting this cleaned up to solve for y. So other than watching your arithmetic, and you have to watch your arithmetic and watch your language when you're doing math. And so so hopefully I have that after I've advertised that I'm going to watch my language and my arithmetic. And so I'm going to get y equals -16x, and then -32 plus 9. And it is okay to use a calculator to do arithmetic with, just to make sure. I like to do it with my head and my calculator, so that when I think that it is something, I can verify. That makes me feel like I did it twice, and I think kind of is helpful. So there's the equation of the line it solved for y. So we did a lovely job on that, and we'll see about problem 4, sorry. Find the slope and the type of line. So we've already used the slope formula today, practicing. Okay. And then it asks to find the equation of the line. So the same kind of equation that they had over there. So I notice here that when I do this subtraction in the numerator, -2 take away -2. Sorry, my phone is going off the rails with people telling me an incident that happened. Okay, let's see. 3 take away, right? 3 take away 5. So in the numerator, this is -2 plus 2, which is 0, over -2. And that is equal to 0. And you do need to reduce that. So all the time people say, I just left it as 0 over -2. You can't do that. You always need to reduce. You always need to simplify. Now the good news is, the reason people haven't is they don't know what the next thing is. They don't know what it is from here to here. That's the reason they're asking, can I just leave it like that? Because they don't know what the next answer is. And the good news is well, you don't have to. Your calculator knows. So all you have to know is how to use your calculator. And I don't know how many times it would be putting it in your calculator and looking at it and getting 0 there that you would start to be convinced that it's 0, right? We went over why that was 0 in chapter 0 is what we did. But now do it, and then pretty soon you'll become convinced. 0. Now remember that all horizontal lines have slope 0, and anything with slope 0 is a horizontal line. They go together. And so I'm like, oh, the slope is 0, so it is horizontal, right? And so another thing I'm getting is people are telling me that it's 2 things at one time, but this, you are one or of these only. You can only be one of them. And so it's a type of line. You can only be horizontal. You will not at the same time be vertical. It's not possible. Or at the same time be slanted. Now the equation of the line, remember the equation for horizontal was y equals, so for horizontal, our equation is y equals a number, And the number is, and they both agree, -2. That's what y is, -2. And in fact, if I was to plot this points, which I didn't, like I had here, right? If I plotted it like I plotted here, although it's horizontal, it's not vertical, but if I did, and I started naming off other points, I would notice that every single coordinate for y was -2. Every single one of them. Not just those two, but every single one of them. And I always get asked, what if these were not the same? And then it would not have been, if they weren't the same, it would not have been zero slope, because it was that they were the same, and you were subtracting things that were equal to one another that gave you 0 in your numerator. So had they not been the same, it would not have been horizontal, and then it wouldn't have been y equals a number. But since they are the same, I could have, some people tell me, hey, I noticed those were the same, so that means the slope is 0, and that means the equation is y equals -2. And oh, great, that's wonderful. You went faster than we did at the thought process, but it's all good there. Okay, so y equals -2, the number is -2. So now it's asking us to find the slope, the x-intercept, and the y-intercept. And from standard form, the x-intercept, this is standard form. The x-intercept is easy. The y-intercept is easy. Okay, so I'm going to leave it in, but the slope is not, it's not easy. It's not possible. So I'm going to leave it in standard form and find the x-intercept. That's what I'm going to do. Because if I rearranged it into slope-intercept form, then the x-intercept is hard. So I want to, while I have it in this form, I want to find what would be easy. So from standard form, this is standard form, the things that are easy are the x-intercept and the y-intercept are easy. All you have to do to find the x-intercept is let y equals 0 and solve for x. So you get 3x minus 2 times 0 in that equation equals 5. And I say this is easy because this always goes away in standard form, right? And then it gives me 3x equals 5. And even if it's a fraction or whatever, it's good. You do not want to write it as a decimal if it doesn't come out to be a nice decimal. And 5/3 is not a nice decimal. It goes off, you know. So you can write it as a mixed number or you can write it as a fraction. There is nothing wrong with a fraction. And so it is not the F word. So there's the x-intercept. You're also free to write it as an ordered pair if you want. The x was 5/3, the y is 0. I think because of room, I'm going to write it right underneath here. Is okie dokie to write it as well, 5/3, 0. Now the y-intercept is also easy. So I'm going to find it. You let x equal 0. So this would be 3 times 0 minus 2 times y equals 5. This is gone. And then all I have to do is divide, right? And most people can do this in their head. I'm writing it out so that you know what I'm doing, but most people are totally capable of doing it in their head after they've practiced it a few times. So that's -5/2. So -5/2. And as an ordered pair, if you wanted, this is 0, -5/2. And so now I want to find the slope. I haven't found it. I just went and found the easy things. And so you can rearrange this equation. Just a second, I'm sorry. Hey Ty, I'm making a video. That's okay. Do you need something, babe? Oh yeah, I don't know of any. I couldn't think of anything. Okay, thank you. Bye-bye. Sorry, they're out shopping and needed to know, and I don't know how to snip that out, or otherwise I would snip it out. So slope-intercept form, he might be able to snip it out when he gets home, the person that just called, actually, so we'll see. But slope-intercept form, all you have to do is get it solved for y. So I'm going to take away 3x both sides of the equation. So this is going to be in slope 3x minus 2y equals 5. I'm going to take away 3x from both sides. I do not care which you write first, the number or the variable on the other side over there, but it is very common to write the variable in algebra. So that's minus 3x plus 5. Then I'm going to divide by -2, divide by -2, divide by -2. You have to do all of them. It distributes. And that's going to give y equals negative divided by a negative is a positive, but 3 doesn't divide by 2. So 3 over 2x. And then a negative divided by, excuse me, a positive divided by a negative is a negative. So this is -5 over 2. From slope-intercept form, which means solved for y. So this is slope-intercept form right here. What is easy, right? We were looking at what's easy. The slope is easy and the y-intercept is easy. And so people say to me all the time, well, which one, standard form or slope-intercept form, should I find the y-intercept? It doesn't matter. They're both easy. There, right there, that number right there, -5 over 2, is the y-intercept. So after I got it in this form, it's very, very easy to find the, and think about it. Well, if x is 0, because that's how you find the y-intercept, 3 over 2 times 0 just leaves you that y is -5 over 2, right? Now the slope is easy too, because the slope is the coefficient of x, which is 3 over 2. So getting it in the form was a little bit of work. Not a lot of work, but a little bit of work. But once you got it in the form, the slope was easy and the y-intercept was easy. They were right there. Okay, number 6 is asking us to graph the linear inequality. And so what we're going to do is first we're going to start by graphing the boundary. And the boundary is the line. And that happens at equals, -3x equals 6. And so the boundary always happens at equals, and the boundary is either solid or dotted, depending on whatever that is. And so this time it is a dashed line. And so because of that. And so you can use whatever to graph the boundary that you want. You can solve it for y and use the slope and the y-intercept if you like, or you can use convenient points. I myself use convenient points. And always people, no matter what you choose, they're going to tell you that your method is harder and that the method they like to use is easier. And so I always say, use whatever method you want. It's all good. I think it's easier to use convenient points. And I always pick, when it's in standard form, x is 0 and y is 0, always. So when x is 0, then y, all I have to do is divide by -3. So that is -2, right? And then when y is 0, put my finger over that, right? 2x equals 6, so when you divide by 2 you get 3, and you can get a checkpoint if you want to get a checkpoint. That makes sure that you hadn't done something silly with your arithmetic, although I haven't done very hard arithmetic. The checkpoint is actually a little bit more work. You can choose anything that you want for your checkpoint. I'm going to choose -3 just because I think that it will make not a fraction, and I don't like to have a fraction. But 2 times -3 minus 3y, I'm putting in x is -3 equals 6. So this is -6 minus 3y equals 6. So this is me, x equals, what I say, -3. And this is me getting my checkpoint. I'm adding 6 to both sides. Minus 3y equals 12. Dividing by -3. So yes, I had to work a little bit harder, but I did get a whole number, -4. And so I'm going to plot those over here. 0, -2. Is this my first time plotting something? I'm not sure if it is or not, but I want to say that if you don't have a way you need to of printing, then you need to make sure that you have grid paper so that your graphs are as neat as people who are using my grid paper. So you need to make sure that you have grid paper. We had talked about you taking your grid paper in class multiple times, talked about, and using your scissors and cutting it, right? And then taping it on your problem on your regular paper. And so that works out really, really well. Don't forget, I'm drawing a dotted line, a dashed line through this. Then the next thing to do, there's steps to graphing a linear inequality. The first thing is to get this line drawn, And the second step, so this is the second step, is to use a test point to get the shading. So the shading is either above or below. And I got to find out where it is, and I'm going to use any test point that you like. And so I usually choose 0, 0 unless the line goes through 0, 0, and this line does not go through 0, 0. So I'm not going to be, I'll be okay on using it. I know that we had one that did go through on the last lab, or somewhere on the practice, something I gave you, I remember that it went through and everyone was like, ah, what do I do? Just pick anything then at that point. So I have 0 is less than 6, and I'm testing, is that true or is that false? And 0 is less than 6, so this is true. And so what that tells us is that 0, 0 is in the solution region. So I kind of have two regions over there. The boundary has separated the grid, all the ordered pairs in the grid, into two regions. This region up here and that region down there, and 0, 0, which is right there, is in the solution region, and you shade the solution region. And so now the line, because it's dashed, is not part of the solutions. It's just the boundary line between the solutions and the non-solutions. So I am shading the solution region there, and so the solutions are above. So we did a lovely job on that. That was number 6. This is number 7, asking you to do the same darn thing. And so the same darn steps. You graph the boundary, which happens at equals. Because this is less than or equal to, we know that it's going to be a solid line when we draw it. And I like to pick convenient points. You can use the slope and the y-intercept if you want to graph it, and in fact it's in exactly that right form, right? I don't even have to do any rearranging to use the slope and the y-intercept if I don't want to. But I would pick x is 0, that's my favorite convenient point, and 3 times 0 is 0, minus 1, so y is minus 1, and then I would pick x is 1. Notice I am not picking y is 0 because it's not in standard form. It's in slope-intercept form. So when it's in slope-intercept form, I pick values for x. That will be nice, and 1 will be nice, right? 3 times 1 is 3. 3 minus 1 is 2. And 2 would be nice. 3 times 2 is 6. 6 take away 1 is 5. So I easily came up with 3 points on there, convenient points. I try to pick points that are not hard, that are convenient. Thus the word convenient points, right? 1, 2. Easy points. You could call them that too, but then that hurts people's feelings when I call them easy points. Okay, and remember that those should be on the same straight line. They definitely look like they are. You should have a ruler and grid paper if you're not able to print, and you should have a ruler if you are able to print. Even an ID or something like that can be used as a ruler, so you don't really have to go down and buy a ruler, although I did notice that rulers were very inexpensive when I was last at Target. So if you wanted to buy a ruler, you could, but you could use already anything to draw a straight line will work. So step 2 is to test a point, and I can see that 0, 0 is on this side of that line. And so I'll probably test, it's my favorite point, so I'll probably test it. And in the original inequality, so in the original inequality, y goes, and in the original inequality, x goes. And I'm asking myself, is this true? Is 0 smaller than -1? Smaller than or equal to -1? And nope, that's not true, right? And so this is false. And what that's telling me is that 0, 0 is not in the solution region. That line, the boundary line, just divided the region into, just divided the plane into 2 regions. One region is the solution region and the other region is the non-solution region. I just found that over here is where this is not solution. This is not solution over here. So if this is the side that's not solution, then this must be the side where the solution is, right? And so I don't have to test another point. I just have to do that reasoning that there's only 2 possibilities, and that line is just divided the ordered pairs. the ones that are solutions. So if you tested this point right here or this point right here, you would find it's true, that it is in the solution region, or any of the infinitely many more points that are on this side. Then here they asked me to graph the the system of linear equations, solve it by graphing. And so I was asked by so many people, do you have to use graphing? It's not my favorite method. And here's the deal, when I grade your test, is that you have to have both lines graphed and you have to have them intersecting at the right spot. So if you started off by using elimination or substitution to find the solution and then graph the lines, so you kind of did it backwards, and you know, because it's gonna intersect where the solution is, then you know, I guess more power to you. But in my rubric, I have that you have graphed this line correctly. Did you graph this line correctly? I would use convenient points. That's just me. And since this line is in standard form, I would pick my favorite points. X is 0 and Y is 0. When X is 0, then Y is 1. Even if it was a fraction, I would still consider it an easy point. And when Y is 0, X is 3. And I'm going to plot those. I'm not going to get a checkpoint, and I'm going to show you why I'm not going to get a checkpoint on this, because I am eventually going to check it, and I have my way of checking it differently than I do usually. So I'm going to draw that line. And I have told you that if I've asked you to use the graphing method, that they will intersect at a whole number point. The book has made that deal with you as well. And so when we go looking here, this is in slope-intercept form, so it's easier to choose. It's more convenient to choose x's. So x is 0, y is 5, x is 1, y is 6 are good points to choose. And so over 0 up 5, that's 6, this is 5. Over 1 up 6, I'm going to draw. And when your points are that close together, friends, that is more chance of having a little bit of a boo-boo. And so because getting those points are so big that the line that goes right through them is difficult, you know, to see. So sometimes when my points are that close together, well, I'm the one that chose them that close together. So something that you can do if you're thinking, oh, I'm not going to get a good slant, and see when I go there, is that going to be crossing at a nice place? And so one thing you can do if you're worried about that is you can pick another value for x that's over here. There's -1, -2, -3, -4. So maybe I pick -4. And if I put in -4 and I do the arithmetic, I get 1. And so 1, 2, 3, 4 up 1. And that just gives one more point, but that one more point helps me draw this just a little bit better through the points. I don't know, for points further apart from one another or make it a little bit easier to be accurate. And that's the best I've done on drawing it, because man, that looks like it crosses right here. And that looks like it's crossing at -3 over -3 up 2, right? So that's what I'm suggesting is the solution, -3, 2. But I want to check it to make sure. I want to make sure that it's right. So in equation 1, x plus 3y equals 3. -3 plus 3 times 2 equals 3. And you can see that that's true. That's -3 plus 6, which equals 3. Great. And equation 2, does it work in both of them, which was y equals x plus 5. So when you put in y is 2 and x is -3, you can see that the two sides are equal to one another, so that also works. So this is a good solution. So that's what I mean by I'm going to check it, right? I have a way of checking it with a third point. I'm going to use the point that's on both lines to check it. So we did a lovely job on that. The only thing I haven't done here is I didn't put arrows on my line, and you really should put arrows on your line. I'm going to go make sure that I put arrows on that one, and I did. I kind of drew it a little bit too far in my craziness, and now I can't erase it. But check all the rest of them, make sure that that I've drawn them. So I see one here that I didn't. I see one here that I didn't put arrow on, that one that was from before. So I'm going to go and make sure I get arrows on all my lines. And so that's good. Now they're asking me to solve the system. They're giving me the opportunity to use whatever method I would like. And so I don't use graphing when it says any method I would like, because if I'm using any method that I would like, then I am not guaranteeing you that the numbers will cross at whole numbers. And if it doesn't cross at whole numbers, it's very difficult to find. So I'm going to use set up for elimination. I'm going to use elimination. It's actually my favorite method. And I'm going to eliminate y. And so I'm going to multiply by 2 here, because that will make that positive 8y, and that will be negative 8y, right? And so, and I'm going to do nothing, and I'm not going to sing the song like I did in my video. Okay, I admit I didn't sing the song. I told you to go look it up on YouTube because I was worried that if I sang it, that they would flag it. I got one of my calculus videos. I played a little tiny part of a song, and it got flagged, and I had to redo the video. So upset with myself because that was so much work wasted for just a tiny song. So I get negative 5x here equals 25. And then I'm going to solve normally. Once I've eliminated the y's, I can solve that normally. I'm almost out of pencil lead. That's what I should have asked for at the store, was pencil lead. And so I'm going to be dividing here. I didn't mean to draw that line like that, but for some reason I did, by negative 5. So x is negative 5, and now I would like to find y, and my solution is an ordered pair, and I've just found the x coordinate. And it doesn't matter if you find x or y first. X is always written first, no matter which one you found first, and y is always written second, no matter which one you found. And you can choose either equation to plug into. You can plug into equation 1 or equation 2 or equation 2 remodeled, and they will all give you the same answer. So I'm going to choose arbitrarily equation 1. It does not matter. So this is negative x minus 8y. Boy, that one's sure a negative equation, huh? Maybe I should have chose the other one, so because it's so negative. 5, positive, right? Negative times a negative, minus 8y equals negative 1. Take away 5, take away 5. Negative 8y equals negative 6. Dividing by negative 8, dividing by negative 8, y equals 3/4. 2 out, right? 3/4. And now I'm going to check it. And so I always check. And the reason I check, even when my video is getting 37 minutes long and I'm wanting to make sure, of course, when you talk about it, it takes you longer to do it than it takes if you just do it. The reason I'm going to check it is because that's the only way to know for sure that you have the right answer, is to check it. And then I have an opportunity to go and find my arithmetic mistake. And so I'm going to check it in both equations, equation 1 and equation 2. And it's your choice whether or not you want to use your calculator to check. It's so funny that if I tell people to check it by hand, then I get hateful emails telling me, can't I use my calculator to check it? Why are you so against technology? And if I tell people to check it with their calculator, I get hateful emails of people saying, why can't I do it by hand? Why won't you show me how to do it by hand? So I can't win for losing, my friends. And so I like to check it with my calculator, and I like to check it with my head. I like to do both. And so I'm getting negative 1 there, and I had not used my calculator to that point in the problem. So I really feel like that's great, that's wonderful. If you wanted to, you could do this by hand. You could definitely check it. A negative times a negative is a positive, so this is by hand, right? I could totally do it. And a negative, this is negative 8, right, over 1, so it's actually subtract. And that's 8 over 1, and when you times it by the 3/4, the 4 goes into 8 twice. And so this is negative 6, so minus 6 here. And so I get 5 take away 6, which is negative 1. So just like my calculator said. So this was by calculator, right? I got negative 1. By hand was here. I got negative 1, and I'm like, oh yeah, I got negative 1. So here I am checking the last one. So negative 2 times x, which was negative 5, and plus 4 times y, which is 3/4, equals 13. So by hand, this is 10. A negative times a negative is a positive. The 4's drop out with one another, and I get 1 times 3, which is 3. So I get 13 equals 13. And I'm like, hot diggity dog, right? And you can put it in your calculator as well, and you'll get the same answer. And so they both checked. This checked out, and that checked out. So that tells me that this is a good answer. The last one to do here, I don't know if I'll make it with the amount of lead I have in my pencil. And so maybe I will. And so anyway, it seemed like I had one more piece in there, but I would use substitution on this. It's set up to do substitution. I like to circle the one that I'm going to plug into the other and kind of draw a line to it. You know, or an arrow to it, like I'm going to plug it in there. And then what I like to do is write the other equation down carefully, 2x minus 3. And then where I'm going to plug in, where I'm going to substitute in, I put a parenthesis. I put it big enough to put what y was, which is 4x minus 1, equals 12. And then now I am physically going to substitute in, so thus the substitution method. And I'm plugging in there for y what it said y was, and then all of a sudden I have something that I can solve. It only has, and it's a blend of the two equations. This was a blend of the two equations too. Do you guys notice I added the equations together? So that made it a blend of the two equations. This only works if one of the variables is going to drop out. So I made one of the variables drop out, otherwise it won't work. And this works only if your equation is solved for one of the variables so that you can blend it. So I have essentially here also eliminated, I eliminated y by substituting it out, right? Here I eliminated y by making them opposites of one another. So this method sometimes is called the addition method because you added the two equations together. Our book called it the elimination method because when you added the two equations together, you eliminated a variable, but actually when you substituted, you also eliminated a variable. So it's called this, you know, I don't care what you call it, doesn't matter. This equation probably just doesn't want to be called late for dinner, right? And so 2x minus 12y, x, rather, sorry, I don't know why I said y. A negative times a negative is a positive, 3 equals 12. So I get right here, I get negative 10x plus 3 equals 12. The answer does not have to be a whole number. And many problems were not whole numbers. So don't think that because I had many people tell me that when the answer became this horrible fraction, well, actually negative 9/10 isn't a horrible fraction. It's actually a pretty friendly fraction. That they thought that they had done something wrong. Remember that your answer should be an ordered pair with, if it has a solution, and it looks like that on this lab I had everything have solution, so make sure you go review ones that didn't have a solution and also ones that had infinitely many solutions. Make sure you review that. Now I would go back to where this is the easiest equation, y equals 4x minus 1, because all you have to do is just do the arithmetic. Y equals 4 times negative 9/10 minus 1. And I would put that in my calculator, but if you want to do it by hand, I say go for it. That would be just lovely if you want to do it by hand. I don't care. It does not matter to me. So that's not the kind of thing that hurts my feelings when you say you would rather do it by hand. Whatever. If I said do it by hand, you'd tell me you'd rather do it by calculator because that's the human condition, right? So this is negative 23/5. If you want to see me doing it by hand, this is 4/1 times negative 9/10 minus 1. And so this is how it would look by hand, right? It would, the 4 and the 10 reduce with one another. You can get a 2 out of each of them. So that's negative 18/5 minus 1/1. And then common denominator 5, so times 5 times 5. So this is negative 18/5 minus 5/5. So now the denominator is 5, and now I'm doing that numerator, which is negative 18 minus 5. They're both negative, so you add them. So 18, 19, 20, 21, 22, 23. So negative 23 over 5. So you shouldn't get a different answer because you did it by hand. That's another thing I've heard this week quite often, is I did it by hand and thus got a different answer. And so you should not. You should get the same answer whether you do it by hand or by calculator. You should always check, even if you're tired. I say check at the end of your test when everything, always check when you're all done, so that if you run out of time, that you don't run out of time and don't finish some problems because you were checking. So at the end of your test, I'm going to have to remind myself to say that on Monday in class to make sure everyone hears it, that at the end of your test, you should check. You should go back and you should plug in. If you've been practicing right along, you should be able to do the test in ample time. I've given you ample time to do it. If you haven't been practicing, then it's much more difficult to do the test in the allotted time, because practicing makes you faster. Also, you shouldn't have to be explaining it to someone, which makes it slower when you're explaining it as you go along. If you're just doing it, it's much faster than telling someone what you're going to do as you go along. So I ought to get 12 there. And if I don't get 12, I know that there's a boo-boo. Uh-oh, I pushed a different button besides equal. Didn't mean to do that. And so, oh, good, I did get 12. So 12 equals 12 here. So I smile to myself. I'm checking. I'm going to check in equation 2. I'm always asked, do I have to check in both equations, or would it be good enough to check in one of the equations? And if you only check in one equation, you might have the wrong answer and only made one arithmetic mistake. It'll likely work in one equation if you only made one arithmetic mistake. So y equals 4x minus 1, right? So this is negative 23 over 5 equals 4 times negative 10 minus 1. And yeah, I know, I just did that, right? Over here, 2 ways. You guys remember me doing it 2 ways? I did that by hand, and I did that by calculator. And so I'm going to go ahead and tell myself that you already did that twice. And so we have it. So we did a lovely job on this smiley face, right? Maybe I would put it in my calculator, but I already did it with my calculator in my hand, so I feel like I've done it. Okay, my friends, there's lab number whatever it was. And we did a lovely job at getting it all solved. And so there's that story there. And okay, I have nothing more to say.